So last class we have discussed about biomimicry, right? So you know what is a biomimicry? Because I explained it very well. അപ്പം കുറച്ച് അതിൻ്റെ എക്സ്റ്റൻഷൻ ആയിട്ട് ഫോർത്ത് മോഡ്യൂളിൽ തന്നെ ഒരു 2-3 പോർഷൻസ് കൂടെ കവർ ചെയ്യാനുണ്ട്. സിമ്പിൾ പോർഷൻസ് ആണ്. ഫസ്റ്റ് വൺ ഇസ് വാല്യൂ എഞ്ചിനീയറിംഗ്, കൺകറന്റ് എഞ്ചിനീയറിംഗ് ആൻഡ് റിവേഴ്സ് എഞ്ചിനീയറിംഗ്. ഓക്കെ, വാല്യൂ എഞ്ചിനീയറിംഗ്, കൺകറന്റ് എഞ്ചിനീയറിംഗ് ആൻഡ് റിവേഴ്സ് എഞ്ചിനീയറിംഗ്. Okay, so I hope you are thorough with the biomimicry. So biomimicry, you can expect questions, is very important in the university point of view. ഒരുപാട് വെയിറ്റേജ് ഉള്ള ഒരു ടോപ്പിക്കാണ് ബയോമിമിക്രി. സോ പ്ലീസ് ടേക്ക് ഇറ്റ് വെരി സീരിയസ്. Coming to the next topic, that is value engineering. So what do you mean by value engineering? So value engineering means it is actually a technique for improving the product, project and process. Okay, so value engineering, it is a process of improving a product and its project and the whole process. Okay, so how you define value engineering? It is actually ratio between the function of the product to the cost of the product. Okay, so value engineering is basically a function between, so it is a ratio between function of a product and cost of a product. Okay, for example, how to improve a material, or you can say how to improve a product. So if you consider from the point of view of value engineering, okay, value, the term is called as value of engineering, VE. Okay, so the value of a particular product. Okay, so how will you define value of a particular product? Okay, how will you define the value of a particular product? That is, you have to think in terms of a designer view. Okay, you are not thinking in terms of a customer view. You have to think in the view of a designer view. Okay, so you are designing a product, so how will you give the maximum value to the product? Okay, so that is value of engineering. That it is a technique for improving the value of a product, project and process. That is, the value engineering is a process, or you can say it is a technique which is applied to improve the value of a product. Okay, that is to improve the value of a product. Okay, for example, if I'm telling for example a printed circuit board, that is PCB. Okay, so how will you see the value of engineering of a printed circuit board? Okay, so first of all, you will study the description. Okay, you will study about the product description. Okay, you will study the product description of the printed circuit board. Okay, so what do you mean by PCB? PCB is an instrument which is used for the temperature controller. Okay, PCB is an instrument that is used for to control temperature in your home. Okay, second one is you will study the reason. Okay, you will study the reason. So reason is PCB. PCB is the appliance is losing market share to new domestic and foreign competitor due to the higher cost of appliance. Okay, so why you are going to start a PCB means nowadays it is losing its importance in market. Okay, the PCB is losing its importance in market. Why? Because of its higher cost. It is really a high cost. Okay, so normal people cannot afford it. So PCB is losing its market. Okay, so more, if you go to the foreign countries, they will be using more PCB. In our countries, people are using it very less. Why? Because it is very it is very expensive. Okay, second one is you will analysis the PCB. Okay, so PCB is modeled with the 10 components, take 8 manufacturing steps in assembly process, excessive weightings and moving time during assembly. Okay, so you will analyze the PCB. How what is PCB composed of? Okay, what is the PCB means what printed circuit board. Okay, so what it is composed of. So if you analyze the PCB, you will get an answer that it is composed of 10 components. Okay, PCB is having 10 components. 8 manufacturing steps is involved in the assembly process. Okay, 8 manufacturing steps is involved in the assembly process. Okay, 8 manufacturing step is involved in the assembly process, and there is excessive waiting and moving time during the assembly process. Okay, so if you go for the analysis of a PCB, if we go for the making, okay, during the manufacture of the PCB, how it is manufactured, you're going for an analysis of a PCB, you will see that the PCB is having 10 components, and it is having 8 manufacturing steps. Okay, and the assembling process is taking a lot of time. Okay, now fourth one is that you will find an alternative concept. Okay, you will find an alternative concept, that is in the value engineering, sorry, for the PCB you are finding an alternative concept. So what is that? So analysis of a component led to the led to alternatives for its procurement, as analysis of assembly process led to the revised layout of assembly line. Okay, so this existing PCB is not feasible. Okay, because the assembling process is taking a lot of time. So in the fourth step, what you will do that you will find an alternative method. Okay, so you will find a technique so that the assembly time is reduced. Okay, analysis easier. Okay, so all these things, all the disadvantages that you found in the analysis of PCB will be overcome in the fourth stage. Okay, that is, you will find some technique to overcome its disadvantage, that it is having 8 manufacturing steps. So that 8 step, it is taking a lot of time. So you will find a way so that the number of steps is reduced to some 5 or 4. Okay, we told that excessive time is required. Okay, during the assembling stage, excessive time is required. So you will find a method to reduce the time of assembly. Okay, so that is a fourth stage, that is as alternative concept, that is you will find an alternative method. Fifth stage is you have to find the advantages, that is the component prices reduced to small degree and assembly time reduced to large degree. Okay, so what you have to, so you have find an alternative method, and now we got a new PCB. So this new PCB, it is assembly time is very less. The new PCB, the assembly time is very less, and also you have reduced value of the product, because earlier it was affordable only for the higher class people because it was expensive. Now that you have reduced the PCB's value so that it is affordable to middle class also, middle class and lower class. Okay, so you have reduced the component price of the product. Okay, the next stage you will analyze the disadvantages. So every product will have some advantages and disadvantages. Okay, so you have to analyze the advantages. Plant layout has had to be changed to reduce the moving and the waiting time. Okay, so there is some advantage that still it is having a waiting time. Okay, so you have reduced the assembly time. Okay, assembly process has been reduced. Okay, and waiting time has been reduced, but still there is the number of steps has not been reduced. Okay, number of steps has not been reduced. Okay, so that number of steps is again making uh, a longer time, or you can say it is again making a waiting time. Okay, so you have to change the whole plan layout. You have to change the whole plan layout. So you didn't change the whole plan layout, but you change some portions, like some steps you have changed, you have altered some steps, and then you have reduced the cost and you have reduced the assembly process. Okay, but the whole plan layout didn't change. Okay, so that is one disadvantage here. Next is results. Okay, result is that the cost of components has been reduced, net cost of manufacturing has been reduced, competitive pricing of the compliance has been achieved, company achieves the goal of the market share and turn to be profitable. Okay, so finally, end of the day, the result of a value engineering should be what? You, the company should be able to gain profit in the market. The company which is issuing PCB should be able to gain profit in the market. Okay, so now that we were doing an value engineering of a PCB. Okay, so in the result, what we have got, we have reduced the cost of the components, manufacturing cost has been reduced. Okay, again the cost has been achievable for the middle class and lower class people. Okay, so earlier it was only accessible for the higher class people. Now the middle class and lower class people can access it. Okay, and next one is by launching this PCB into market, the company had got a profit. Okay, that is the company got a that is people started buying it, so company has got a product. So that is a value of engineering. Okay, so value of engineering means what? It is a value of a product. Sorry, the value of engineering means it is a technique which involving, sorry, it is a technique which is for the improvement of the cost of the product. Okay, which is for the improve, that is end of the day you have to improve the cost. Okay, so here what we have done for, I have told you with an example, that is a PCB, printed circuit board. Okay, so earlier the PCB means that it is used to control the temperature in a home. It was accessible only for the higher class people because it is very expensive. So you have made some alterations, you have analyzed it, you find an alternative way, you've studied about the advantages, you studied about the disadvantages, and finally end of the day you have launched a product which is accessible to all class of people, and company has achieved its market. So that is value of engineering. Value of engineering. Next one is concurrent engineering. So what do you mean by concurrent engineering? So concurrent engineering means it is an approach in the product design process in which people from the various functional areas work together simultaneously to develop a product. Okay, so concurrent engineering is an engineering where people from the different areas will work together to develop a product. Okay, for example, I can say with microbial concrete. Okay, so what do you mean by microbial concrete? So microbial concrete is a concrete where you are adding microbes to the concrete to improve the strength. Okay, you are adding bacterial culture to the concrete so that the strength of the concrete is increased. Okay, so it is said that bacterial concrete is having much more strength than the normal strength. Okay, so if you study about the bacterial concrete, you can say the concrete. So basically civil engineers know about the people who are graduated from the civil engineering, they will be know about the concrete cubes, all these things, but they doesn't know about the bacterial culture. Okay, they won't have much, the civil people, they won't have much information about what kind of bacteria should be added, will the bacteria will be able to survive, what kind of bacteria will be surviving, will the bacteria die off, will the bacteria live in it. Okay, so there are, not every bacteria cannot be cultured, there are certain types of bacteria which can be cultured and which can be added to the concrete. Okay, so that group, that is a biotechnology group. Okay, that bioculturing of this bacteria, that comes under the biotechnology. Okay, so alone a civil engineer cannot do this. So what he need help from the biotechnology department. Okay, because only they know how to culture a bacteria and how to properly add this bacteria in the concrete. Okay, some bacteria will be die if you add to concrete, because there are chemical reactions are occurring. Okay, so you have to choose a bacteria which will live in the concrete. It is able to make some result. Okay, so biotechnology people, they are involved. Okay, okay, so at the same, so these two people are working together to develop a product. Okay, so these two people are working. That is, alone a civil engineer or alone a biotechnology person cannot develop a microbial concrete. He need help from the biotechnology department. At the same time, biotechnology person, they doesn't know anything about the concrete casting, all these things. Okay, for the concrete we need to know about the mix, ratio, proportion, grade, everything we know. Okay, sand, sieve, all these things, the certain quality, everything. Only civil people will be able to know that. So they also doesn't know anything about it. Okay, so these two peoples are combining together to develop a product. So that is a concurrent engineering. That is, it is a attempt in which people from the various functions, okay, people from the various functions, they are working together to develop a product. Okay, okay, they are working to develop a product. Okay, so that is basically concurrent engineering. So since people from the various fields are working simultaneously for the development, this kind of engineering is also called as simultaneous engineering or parallel engineering. This approach is adopted to improve the efficiency of a product designs and reduce the product development cycle time. Okay, so since people from the various engineering stream is involved in the development of the product, this is also called as simultaneous engineering or a parallel engineering. Okay, sir. This you might have observed in most of the company. If you watch, they will be having some mechanical wing, they will be having some CS wing. Okay, they will be also having some civil wing, because alone this cannot function. Okay, the alone a company, they need some help from the mechanical stream, they will be needing help from the CS team, they will be needing help from the IT team. Okay, so all these will be working together. Okay, so since simultaneously people from different engineering streams are working together, it is called as simultaneous engineering or parallel engineering. Okay, so why we are using this concurrent engineering means mainly to improve the design efficiency of the design. That is mainly to improve the efficiency of the design and to reduce the product development cycle time. That is, the things that can be developed in 1 year can be developed within 6 months or 5 months. We can reduce the cycle time. Advantages of CE, concurrent engineering. Okay, so if you adopt CE, what are the advantages? That is, it will reduce the design time. Okay, that is, design time can, that is something, the product which can be manufactured in 1 year can be manufactured in some 6 months or 5 months. Okay, it can reduce the manufacturing, it reduces the cost of design changes, it ensure the correct data and information transfer between the various sections. Okay, that is, for example, like I have told microbial concrete. Okay, so there requires a proper data of information. Okay, that is, the civil person, he need to have the proper information about the biotechnology part, and the biotechnology person, he need to have a proper information about the civil part. Okay, so that combinedly we are working. That is, a person, for example, a person A, he want to develop microbial concrete. Okay, so he need information from the both side. Alone he cannot work with a particular stream. Okay, a civil engineer alone cannot work with a civil stream, so he need a proper information from the both the streams. Okay, so in the concurrent engineering, it will ensure the correct data information transfer between the various sections. Next is simultaneous thinking leads to the amazing information. So this can sometimes lead to amazing innovations. Likewise, I'm telling, microbial concrete is actually a recent development which has occurred. Okay, so in our country we are not using it because our country is still on a developing mode, but the investigation is still going on. Okay, so it is said that if you in the bacterial concrete, you can add your starch water. That is, നമ്മുടെ കഞ്ഞിവെള്ളം, നമ്മുടെ വെള്ളത്തിൽ നമ്മൾ കളയുന്ന കഞ്ഞിവെള്ളം. So that starch water, it will be acting as a food to bacteria, and it will improve the strength of the concrete. That is, above 40 to 30 to 40% of the strength will be increased. Okay, if the normal, from the apart from the normal, 30 to 40% of the strength will be increased. So that is amazing innovations, right? That is an amazing innovations. So every person has a feel of belongings to the product. So, and you will have a feel that like microbial concrete means it. You will have a feel of belongings. That is, civil will person will have feel that okay, so this is something related to me. So when the biotechnology person, they will be also having, oh, this is something related to me because everybody has contributed. Okay, so there is a contribution from every stream. So there is a feel of belongingness. So that is concurrent engineering. Okay, so there are a lot of examples of concurrent engineering. If you go out and if you see every engineering device, okay, engineering device, it will be involved. It will be there will be a simultaneous uh, help from the all different streams. Okay, if you, for example, if I'm taking a building, okay, building as a whole, okay, civil structures, basically civil people, what they will do, they will be making the structures. Okay, interior design, that is another department. Okay, the interior of the building will be done by interior designers, so that is another department. Okay, so interior designing is, we are not studying anything about the interior designing. Okay, in the 4 years of this BTech, you are not studying anything about the interior design. So interior designing is another course. Okay, so they will come and they will do all the interior designing. Okay, then architectures, landscaping, architecture, they can create a beautiful building. Okay, the aesthetic view of a building. So that is mainly an architectural view. Okay, landscapes, gardens, lawns. Okay, so architecture people, they will be able to contribute more to the aesthetic view of a building. Okay, so it is a combination. So that is concurrent engineering. Next one is reverse engineering. Okay, reverse engineering. So reverse engineering means, okay, I can best example tell you reverse engineering, that nowadays we are having a problem of a plastic wastage. Okay, that is plastic. We don't know where to dump this plastic. It is actually non-biodegradable material. Okay, but recently you might have seen that plastic, people are efficiently crushing the plastic and they are using it different forms, like they are using it for as a reinforcement to the building. That is plastic bottles, they are filling sand into this plastic bottles and they are using it as a reinforcement to the building. Okay, instead of steels, they are using reinforcement to the building. That is actually a material that we are throwing. Okay, so what is actually happening here? So in the daily, you can say in our daily life, we are throwing different materials. We are throwing a lot of materials. Okay, so reverse engineering is an approach where the existing product is analyzed and another product is developed in the light of analysis. That is, in the reverse engineering, you will analyze the existing product. Okay, you will analyze the existing product and another product will be developed in this light of analysis. So everything that is developed will be in this sequence. Okay, ഒരു evolution mode ആണ്. Okay, everything that is developed will be having an evolution. If you see your mobile phones, like mobile phones in 90s, people were using torch phones. Okay, people were using torch phones. Sorry, 90s, not in 90s, in 2000. In the 2000s, that is the time when mobile phones came. Okay, so 2000, people were using torch phones, battery phones, lead phones. Okay, so someone has thought this existing product has to be developed in some different way. And what a smartphone came, Android came, touch phone, Blackberry, iPhone, all this came. Okay, so now that everybody is having a smartphone, every approach in which existing box. Okay, iron box, that is Okay, so this is an iron box. So iron box in prior, that is in the olden traditional time, people used to keep that burnt coconut shell to that iron box. It will be having a mass shape. It will be very big in size, and you will be adding this burnt coconut and some charcoal in it, and then you will be ironing your dress. Okay, so with the passage of time, you have developed an iron box which can be used with the electricity. So now it is very simple. Like, you just need to on the switch. Okay, so that is a new product has been developed. So that is reverse engineering. Okay, that is a reverse engineering. Okay, so product that is analyzed can be on product or on product of the producer or a product from the competitor. So you can anything you can be analyzed. Okay, so in see now the mobile phones, we can say laptops, your TVs. Okay, prior we are having YouTube TVs, but now everybody is having LED TVs. Okay, or within 5 or 10 years, this LED TVs will also go. We'll have a new TV. Okay, we'll have some other TV, some touch TV, something like that we'll have. Okay, even this mobile phones also will have a new version of mobile phones. We don't know what it is, but it will come. Okay, the mobile phones now that you are using will be thrown. Within 10 years, you will have a new mobile. So it's some new techniques. Okay, so that is a process. That is existing product is analyzed and a new product will is developed in the line. A new product will be developed. So in the reverse engineering, a product is dissected and disassembled to find out the details, how a parts work and why it is used. This information is obtained by this process and can be applied to solve on design problem or a new product. So what is happening in a design engineering? So the exact process that is happening in design engineering, that you will have a product. You will disassemble the product. That is, you will നമ്മൾ ആ പ്രൊഡക്റ്റിനെ മുറിക്കുന്നു. മുറിക്കുക in the sense you will disassemble the product. Okay, you will disassemble the product and you will see each and every part, how it is working and why it is used. Okay, so that will give you a new idea that why can't you uh, use some other product instead of this? Why can't you replace this product with this? So you will get a new ideas with it. Okay, so that is how reverse engineering is working. That is, you will have a product, you will disassemble the product, and you will study each and every parts. Okay, so while studying this each and every part, you will get new ideas. Why this part can be replaced? Why can't we use this product instead of this? Okay, so this will lead to the development of a new product. So reverse engineering is essentially a functional decomposition process in reverse engineering. Okay, so it's a functional decomposition process. Okay, that is, a function is decomposed into a new process. An existing product is analyzed into sub-I systems, which are further analyzed to deep to ultimately establish the product concept. This analysis will help the designer to identify the weak side of design. Oh, so that's important. Okay, that is, by we have discussed in earlier that you will be disassembling the product. You will be disassembling the product and you will be studying each and individual part. So while studying this, you will be able to study the weak side of the design. Okay, design ഏറ്റവും വലിയ പോരായ്മ, that is weak side of the design can be studied, and this will help you to the development of new technique. Okay, this will help to, that is if നമ്മുടെ latest ആയിട്ടുള്ള cars. Okay, now that you are having automatic gear, right? Okay, the steering is also power steering. Okay, so earlier if you go to the 90s 80s times, we don't have that power steering. Okay, people has to rotate the steering. Okay, one whole revolution with 360-degree you have to rotate to take a turn. But now we are having power steering. Power steering means what? You just have to tilt the steering. Okay, just tilt it. Just need to tilt the steering. And then now the latest is you are having gear. Okay, automatic gear is there. Okay, so Okay, so mainly we are having 4 gear. That is first gear, second gear, third gear, and finally reverse gear. Okay, fourth gear is also there, but okay, fourth gear and reverse gear. So people who people who are driving, they will know the disadvantage of the gear. That is mostly we will be mostly what we'll do is that we will forget to change the gear. Mostly you can see you will forget to change the gear. Okay, but especially for the starters, they'll be always forget to change the gear. So that is a very big problem. But if you go for an automatic gear, you don't have that problem. Automatically the gear will be changed. Okay, so that is one disadvantage that has been studied. The weak side of the design has been studied, and a new product has been developed, that is automatic gear. Now again we are having electric vehicle. Okay, you might have seen electric vehicle which is having a green plates. Okay, green plates, electric vehicle, that is the vehicle is running on a batteries, and even the government is providing free charging centers. So imagine, one of the main problem that is faced by the drivers is the petrol cost is increasing day by day. Okay, so that is now it has crossed 100. Okay, so if you are going for electric, that's a one big disadvantages. Okay, so now that we are having electric vehicle means we can charge. Government is starting free charging centers. It is working on battery, so you don't need petrol for it. And also it is producing less pollution, very less pollution. So petrol and diesel vehicle unit is emitting a lot of gases into atmosphere. Coming to the electric vehicle, it is producing very less emissions. Okay, so that disadvantage has been studied, and we have got a new product. Electric vehicle means that is a brand new product. Okay, so that is reverse engineering. That is this an approach where your existing product is analyzed and a new product is developed. Okay, so I hope you have understood what it is. Okay, anyway, we'll discuss one small question from this portion. So this is one university question. Okay. So that's the end of this module. Okay, that's the end of this module. Okay, I don't know what question is. Okay, we'll do one thing. So now you can post your name to mark the attendance, okay? So actually, I don't. So I think for the not for the series, there is a university question that is related to biomimicry. I didn't get exact question right now. Okay, so question was like this. That is, you have to design a solar power bus waiting shed. Okay, solar power waiting shed, taking inspiration from the nature. That is, taking inspiration from the nature, you have to design a bus waiting shed. So how will you design? That's a question. That's a university question that has been asked. So how will you design? So from the question itself, we can understand this is related to biomimicry. Okay. So what they have told is that you have a solar bus waiting shed. So bus waiting shed usually what it is having a shape of rectangle or triangle. You might have seen. Okay. So from the nature you have to take inspiration. Okay. So imagine the nature. Okay, from the nature, how will you will take the inspiration. That is a shape of a base waiting shed. That is sometimes you can take a shape like this. Okay, the leaf shape നമുക്ക് എടുക്കാം. See, something. This is a leaf shape. Okay, so this leaf shape, you can make a bus waiting shed like this. Okay, this is a leaf, so people can stand over here. Okay, so that is from the nature you are taking this shape, bus waiting shed. So this is a leaf structure. So you can make, so this will be very huge and people can be accommodated below it. Okay, that is one from the nature. Second one is this, you might have seen so many ice cream parlors, a structure like this, like mushrooms. Okay, this is also a structure that is adopted from the nature, so people can stand below it, waiting as a waiting shed. Okay, so that is from the nature you have selected the structure. Okay, that is a shape of a mushroom. Okay, so this is how you have to answer these kind of questions. Okay, that is a university question. I think now time is up, so thank you.